On a previous video I talked about this switchable attenuator I'm making, or variable attenuator, for my test equipment, and it comprises of quite a spider of different value resistors, and it's 6-position switch, and when operated it gives attenuation in decibels to low power RF signals such as a signal generator, etc. Position number 1 is 1 decibel, position number 2 is 2 decibels, 3 decibels, position 4 is 5 decibels, etc, etc, and the top decibel is 20 at position number 6. So that's the resistor part of it, and switch. Now obviously I've got to mount some sockets, so using this white box material again, I'm making this little box, or I've made this box, and I've sprayed it black as I normally do to match my other test equipment sitting over here in the garage. I'm just taking the screws out, the paint's dry now, and what I'm going to do is attach the SMA sockets, the switch, and do a bit of soldering, but I don't think I'll be able to show you my soldering when I'm doing this because it's quite tricky, but I might show you it once the soldering's been done. Now with the cover off you can see the white plastic and the white plastic front, and now inserted the SMAs. I've got to put the nuts on the inside and the screen eyelets, which I've got to solder some bits of wire on. Then I should be able to insert the main switch into the box. It's a bit of a tight squeeze. Yeah, you're going to say, well, shouldn't it be a screen box? Well, yes, it should be, but it's so fiddly to get all this in this box. So what I'm going to do, I'm going to put it together as it is, and if it causes problems because it's not screened, I'll put a screen in it. In fact, I'm 2 minds whether to do it actually. I don't know. Can't make up my mind. Maybe I should do it, I don't know. I'll see if I can find the material first, see if I've got any left. Admission time. I think this is the worst bit of soldering I've done in a long time, but to try and cram that amount of resistors into this box is going some, I must admit. I didn't go for the screening. If I need screening, I'll add it later. I'll put it on the multimeter in a minute and do some tests to see what the resistance is. And yeah, see how it goes. Okay, that's it basically finished apart from decals. 2 sockets on the back, they're not actually in line, but that doesn't matter. It's the worst soldering job I think I've ever done. It's a right pain, this unleaded solder. It's horrible stuff. I don't like it at all. Anyway, I've checked the DC resistance against the original design, which I got from the internet. It's not my design, with the resistor values, and DC wise it steps through okay from 1 dB to 30 dB with the right DC resistance values. It's 50 ohm impedance in and out. I'll need to test it, and what I think I'll do, I'll try and find a constant radio signal and put this in series with the aerial and then just see how it reduces the S units on receive. As a very basic test, until I get my signal generator on it with my spectrum analyzer, and I'll be able to look at how it drops down with that, or even my VNA network analyzer might do the trick as well with the signal generator, because I can put it straight through and then I can adjust it and it should drop the amplitude down on an AM signal, and that would be a good test. So not a very good video this one, but thanks for watching. It just shows you can make some of this stuff yourself, although it may not be as slick finished as some of the professional bought stuff, but on a limited budget, a few resistors, a switch, a box, some connectors and an old knob, and that does it. So thanks for watching. Please subscribe and like. My next video I think will be comparing some shortwave receivers.